In this section, we are going to see the important CCNA question and answer for the interview. So the very basic questions we will start with, like interviewer can ask us on as a network engineer interview that what is OSI model. So there are multiple things that you can specify on or you can say about the OSI model. The first thing that is important about OSI model is it is a reference model. Okay, and it is used to understand how communication works in computer networks, and it breaks down the functions in 7 layers. So you can see these 7 layers are there, and furthermore it creates a standard for network equipment manufacturing. For example, if you take Cisco or Juniper, okay, for manufacturing devices we need standards. For example, RJ45 connector. So that RJ45 connector is a standard connector which easily fits into Cisco devices or Juniper devices, but it can easily also fix in some other companies or low cost companies devices also, like D-Link or TP-Link. Okay, so because of standard it works well, and if you purchase that RJ45, it's cost very less, like you can buy it in 5 rupees, 10 rupees. Okay, and it fits in a crores of rupees device. If you take Cisco Nexus switches, it cost in very high, it has very high cost, but because of standard it works well. And furthermore, the availability of the devices also becomes easy. Means you use a laptops with the HP or Dell, and you use a router with Cisco or some other companies, but they works perfectly fine because all of them are using some kind of standards, and that standards are those standards are promoted by OSI reference model. And it allows a vendor to focus on their specialized area, like Cisco will focus on the lower layers like physical data link and network, whereas the software companies like Microsoft, Red Hat, they will focus, or Adobe, they will focus on the upper layer like application, presentation, and session layer. Okay, transport is partially in hardware and partially in software. So the lower layers are dealing with hardware, the upper layers are dealing with the softwares. Next, we have a question like what is TCP/IP? So TCP/IP is a protocol stack or protocol suite which consists of 5 layers: physical, data link, internet, transport. In some documentation, it is mentioned as network interface layer, means 4 layers only. But this is more common representation of TCP/IP, where we have physical, data link, internet, and transport and application layer. Okay, every layer has its functions. Like if you take the network, if you take the lower 2 layers, data link and physical, so it controls the hardware, device, and media. Right? So under this we have protocols like Ethernet, MPLS, frame relay, and on internet or on the network layer, it determines the best path through the network, and the protocol associated with this is IP, ARP, or ICMP. Like on transport layer we have TCP, UDP. So support communication between diverse devices on the diverse networks, right? And an application layer we have DNS, SMTP, POP3. These are the application layer protocols. So process to process delivery is done by transport layer, and user interfaces is provided by the application layer. So if you compare OSI model and TCP/IP model, so TCP/IP is actually implemented in our machine. If I show you, like if I go to the command prompt and if I run command ncpa.cpl, so here I'm using this Wi-Fi network, right? If I go to the properties here, and if I go to the TCP/IP as well as TCP/IP v6, these two protocol stacks are available for us, right? So if I want to change the properties of this, I can make the changes on this, but uh, right now it is not required. But we can make the changes on TCP IP setting. Likewise, we don't have anything on OSI here. OSI is a totally conceptual model for us, whereas TCP IP is practically implemented on the computers. Next protocol that we have to understand, or the question can arise on that, is what is UDP. So we have TCP protocol and we have UDP protocol. If you compare TCP and UDP, so UDP is a faster protocol. Reason it has a less overhead in terms of, if you see the header of UDP, it has less number of fields, and we don't have to work on synchronization. It's like a broadcast kind of message. Means you just send the data and you don't worry about the reply of that or acknowledgement of that. So just like a radio broadcast, okay, or just like a uh, delivery of of the letters. So the it's a normal postal card letters, and we don't have to worry about whether this letter is delivered or not. Okay, so it is much more faster than TCP. If you compare it with the TCP, TCP has to take care of the synchronization. Okay, where sender and receiver has on the same flow, right? UDP is just best deferred delivery. Okay, so you can see these protocols like FTP, Telnet, SMTP are based on TCP, whereas TFTP, SNMP, and RIP is based on UDP. Next important question, what is HTTP or what is HTTPS? Okay, so HTTP, you can see here, this is HTTPS. In secure environment, we have HTTPS, but in a normal website, we have HTTP. Okay, so for web services, we require this HTTP protocol, which is based on TCP, and the exact port number is port number 80 is used for this. We have different methods in that, like HTTP GET, HTTP POST. Okay, and the secure version of this is HTTPS, okay, which works on 443. So most of the website nowadays are working on HTTPS. Okay. So this is a most common protocol used um, in enterprises, and this should be allowed on the firewall, or it should be allowed on ACL if we are restricting the traffic. Next important question is FTP. So what is FTP? So FTP stands for File Transfer Protocol. This protocol is again TCP based, and it uses two port numbers. One is 80 and the other one is TCP 21. So 20 is used for connection establishment, whereas 21 is used for data transmission. So this is also one of the common protocol, and we can use a software for a small organization. We can use a software like FileZilla. So I have already installed this. So this is a FileZilla server that we can run on this. Okay, and I can configure a user. For example, I configured user Linux here. So likewise, we can configure a user and share a folder with this. Right? So whatever we want to share on this FTP sites, we can share it. On Linux also, we have services like a VSFTPD service that can help us to set up this FTP server. Next important protocol for us is Bootp. So Bootp is predecessor to DHCP protocol. DHCP and Bootp serve both serve the same purpose. In DHCP, we get the IP address with the help of DHCP protocol. Same in Bootp also, we get the IP address. So IP address and configuration for release. So purpose of Bootp and DHCP is same, but the working is little different. In Bootp, the configuration is manual, and so there is a mapping IP to MAC, and It's not based on lease actually. And Bootp client Bootp client can get only IP addresses. Only Bootp clients can be served by Bootp server. Client can be served. Whereas in DHCP, it is backward compatible with Bootp. So it gives the assigns the IP address on the lease basis, or it provide and config on lease configured. Furthermore, this is backward compatible, so it provides IP to DHCP and Bootp client. So nowadays we don't use Bootp actually, but in any legacy device, if you may find Bootp, so that may be the case. But most of the time you will see DHCP. So DHCP, we use DORA process in this, that is discover, offer, request, and acknowledgement. So discover is the message coming from client machine, and it is a broadcast based message. So it reaches to the server, and server offer a IP address, and then client again send a request message, and at the end acknowledgement message works. So it again works on UDP port number 67 and 68. So 67 and 68, these two ports are used. So on the client side, on the server side, this port number is used, and on the client side, this port number is used. Next one is what is SSH, secure shell. So it stands for secure shell. It is used to connect with the router, switches, or server, okay, in a secure way. So remote access, we can use it for remote access of a router, switches, server. It again works on port number 22 of TCP protocol. Okay, so it is a connection oriented protocol. And here public key, private key is also used. The next important question is, what is a router? So router is a layer 3 network device. Why we say layer 3? Because it works on IP address or logical address. Logical address in most of the cases IP address, but we can have IPv6 address, and on the older system we could have a IPX system. This device is used to connect multiple networks, like we could have LAN network, WAN, right? Internet connected by router. So router provides interconnectivity between different networks on the basis of IP address. Okay, and that's why we call it as a layer L3 device, means layer 3 device. Layer 3 device means network layer device. Okay. So it works with the help of different routing functions like static routing, dynamic routing. Okay. So the most common one in the smaller environment is a default route. But if we are using it in enterprise, we can use a routing protocol like OSPF or BGP, okay, EIGRP. These kind of protocols we can use for our routing table to be populated. Next important question is, what is switch? Switch is a layer 2 device. Why we are saying layer 2? Because it works on physical address. Physical address in LAN environment means MAC address, and it connects multiple end devices as a downstream, and it connects to the router and switches as well, okay, as the upstream devices. So normally layer 2 devices, layer 2 switches are used as access layer switch, and layer 3 switches are used as a distribution layer switch, means the upper layer switch, where all departments are connected together, and from there it is connected to normally a router which works as a core layer device. So end devices can be PCs or servers, okay, and it can connect to a router as well. But router will not be considered in end device, so we will consider it as a separate entity. Next important question in our discussion is, what is firewall? So firewall works on multiple layers. Normally, we treat it on the TCP UDP protocols on the basis of TCP UDP protocol. If it is a legacy firewall, it blocks the traffic on the basis of particular services like web service should be allowed, DNS service should be disabled, right? So uh, firewall is a network device which protect our inside or internal network from connections. It prevents unwanted connections coming from external network. External networks could be external network most of the time is internet, but partner network can also be considered as partner means, for example, business partner. Suppose Cisco is business partner with Microsoft. So any connection coming from Microsoft can be scrutinized or cross-checked with the firewall. And if it is unwanted connection or if it is not required connection, that will be prevented by firewall. Okay, so it is a secure, basically it is a security device. That will be a first point in our answer, network security device. So we can say it is a network security device, and it protects our internal network. Next important question is proxy server. What is proxy server, or what is proxy in network? So let's try to get the answer for this question. What is proxy? So again, proxy is a kind of a hardware device, or it can be a software device or software entity device. So for example, this blue code is hardware, proxy hardware that we normally use in production. Okay, or it can be software running on Linux, some kind of operating system. So Squid is the most common proxy server used on Linux operating system. What is the basic purpose of this proxy server? So it is used for filtering network traffic, filter and network traffic, and it prevent access to certain website, to prevent access to certain website which is not related to our business. For example, website like gaming website or gambling website, right? Or dating website. So we want our employees to be restricted to visit those websites, so we can block it from there. It can be used for monitoring purpose also, to monitor user activity. We can specify quotas or limitation also. Okay, and it can be used to hide origin connection, or we can say our internal server as well. So these are the few important points related to proxy. So example I gave you here, like a blue coat proxy, and it could be software, for example, Squid proxy server. Next important point in our discussion, or next important question in our discussion, is different cables that used in LAN. So we have Cat5 cable, right, which has the speed of 100 Mbps. Then we have Cat5e with the speed of 1 Gbps, and Cat6 with speed of 10 Gbps. So these are normal LAN cable. We have fiber optic cables also in these things, but that's a separate discussion. Here we are intended to discuss this different category cable. Okay. Next question related to again cabling is, what is the maximum length of UTP cable? So the answer for this is 100 meter is a standard length. And if you want to go beyond this, we can use fiber optic cable. Next question is again related to cabling. So what is a 100 base FX? So 100 here refers speed, 100 Mbps. Base means baseband, and FX means using a fiber optic connection. Next important question in our discussion is subnet mask. So subnet mask dictates which portion is a network portion. So it dictates our subnet mask network and host portion of IP address. So if we take example like 255.255.255.0 means 255.255.255 is network portion and 0 means host portion here. So it uses binary ANDing in the background, binary AND operation, and with the help of this binary AND operation we get the exact exact network portion and the host portion from the IP address. So for class C, this is a subnet mask. For class B, we will have 255.255.00 subnet mask, and if we take class A, 255.000 is a subnet mask. Okay. Next important question is what is loopback address? So 127.0.127.0.0.1 is used as loopback address, but we can use any IP address from this range. Okay, and it is used for testing purpose. So it works as a self test whether network is TCP/IP stack and the hardware or drivers of that computer is working for the networking or not. So we can run command like ping 127.0.0.1, and if we get a reply there, then there is no problem on the computer from the driver point of view or from the software point of view. Next important question in our discussion is ARP. What is ARP? So ARP stands for Address Resolution Protocol. So if we know the IP address of the other computer with whom we want to connect and we don't know the MAC address, we send a broadcast request and we get a reply back in the form of unicast where the particular IP address and MAC address is mentioned. So it maps IP address map with MAC address. Okay. How we can check in a Windows machine, ARP-A is the command. So from there we can find out what is a MAC address for a particular IP address. Okay, so ARP table is very important. So if we don't have a MAC address of the computer with whom we want to connect, only IP address if we have. So first of all, the MAC address will be collected and then the packet will be formed and it will be destined to that particular computer. For ARP, we can run a command here like ARP-A. Here we can see the ARP table. Right? So this is, I have multiple multiple IP addresses. Okay. So the one which I'm using here is this one, right? So associated MAC addresses, IP addresses, and the MAC addresses are listed here. Okay, and we can delete this with the ARP-T command. Next important question for us is what is network layer? So network layer is a third layer in OSI model. So what are the important functions of this network layer? So network layer, the important function is provide best path to packet, and it provides logical address as well, logical addressing. For example, either IPv4 or IPv6 IP address or IPv6 address. The PDU format on this protocol data unit format, PDU format is packet. So with the help of this IP address and the routing table available in router, the best path is provided, right? So the major device which works on this layer is the router, but firewall, if providing a routing function, any device which provide a routing function can be considered as a router or the network layer device, but predominantly a router is the device which works on network layer. Beside this, we have another question like data link layer. What is data link layer? So let's have an answer of this as well. So this is OSI model second layer. So here we have physical addressing, for example, MAC address, and it provides a error detection function as well with the help of frame check sequence, FCS, available as a trailer, right? and it it provide a linking between the medium as well as medium to the network layer. So LLC stands for logical link control. So we can have wireless media or we can have wired media. Accordingly, this things will be conveyed to the network layer, and this interface is provided with the help of data link layer. So in data link layer, we have two sub layers, that is LLC and MAC, right? So LLC stands for logical link control, whereas MAC stands for media access control. LLC provide services to network layer. It hides details of data link, like what kind of media we are using, whether wired or wireless. Okay. In IEEE, it is termed as IEEE code wise 802.2. It it gives an establishment and control of logical link between local device, whether it is a wireless or wired, to the network layer. Next question in our discussion is MTU. What is MTU? The MTU stands for maximum transmission unit. Normally on Ethernet link, it is 1500 byte. So if we are sending data, like suppose 3000 bytes, then it will be segmented into, it will be fragmented into two chunks. Okay. So if we receive a packets with the size more than 1500, so it will be fragmented. Okay. And there is a provision to identify a fragment. In IP address, uh, we have an option for this. To a fragment offset option is there, and the different bits are there, don't fragment bit, and more fragment bits, right? So these kinds of options are available in IP header. Next important question is, what is ipconfig? So ipconfig is a command for in Windows. We have this command, Windows OS, to get IP configuration, IP address, subnet mask, gateway, or default gateway more appropriately, default gateway, right? And if we give few more switch on this, like IP config all, it gives information about DNS and DHCP server IP as well as MAC address. Next question in our discussion is what is traceroute or traceRT? So in Windows we have traceRT command. If I just show you the implementation of this, traceRT 8.8.8.8. So 8.8.8.8 is the IP address of Google DNS server. So which hops are there in between? Like this is my first hop or the gateway, right? Then intermediate, whatever hops come in between, that will be shown, right? So it uses ICMP protocol, and more specifically ICMP TTL timed out, okay, or TTL expired message is used in this. Okay. And with the help of that, we can find out how much time we require uh, to reach to a particular destination, and what particular IP addresses are in between. Okay, so if I give you an example with the diagram, so suppose we are running trace route from this router to this router, but in between we have a direct lease line, but due to some reason this lease line is not used, and we have a internet connection or some kind of other MPLS connection or some other kind of connections we have, right? And if we are taking this path, and here we have multiple router in between, suppose in this cloud we have three routers, and if we see four hops or three hops, four hops in between, right? So we will see that this path is not used. Okay, so we can find out what is the problem associated with this. But to get a realization of the problem, first of all, we have to run this tracert command. Or if it is getting stuck somewhere, so if suppose the packet is, we have to send the data up to this, right? The server, but it is stuck on this particular router only. So we can cross check that we can reach up to this, but because of cable connectivity or due to some switch issues, right? So if there is an issue further ahead, so we can reach up to this point, and this point onward we are facing issues. So we can come to this conclusion, right, with the help of tracert or traceroute command. So in Windows, we have tracert command, whereas for Linux and Cisco router, we have traceroute command, and here we have tracert. It uses it uses a ICMP protocol, and especially TTL expired message. We want to get exact code for this, we can find it out from here, ICMP codes and types from INA website. TTL time exceeded is the code for TTL exceeded in transit. Okay. So it is very important tool from the network engineer's point of view for the troubleshooting purpose. Next important question for us is, what is DNS? So DNS is domain name system or service. Okay. It works on UDP, book number 53. It uses TCP as well, TCP 53, but that is for server to server zone transfer purpose only. Most of the time we are using this one. Okay. And what is the basic purpose of DNS? It's convert, you can say convert host name to IP address. Okay, so DNS servers has has a mapping of host name to IP address. This mapping is called as records, and set of records are called as set of records as a collection is zone file. Okay. So this zone file has most of the A records, and we have reverse also, like IP address to host name, that is pointer record. But A record is the common one, and chord A record is for IPv6. Okay. So public DNS server like 8.8.8.8 is a Google DNS server. Likewise, we can have different corporate DNS server as well. Okay. Next important question here is, servers reachable via IP address, but not through host name. Obviously, this problem is DNS issue. So DNS, first of all, we need to check TCP IP setting. We should look for DNS server entry. If DNS server entry is misconfigured or not available, first of all, we have to configure that. Okay. If it is provided by DHCP server should provide a correct DNS server. Next, DNS server should be reachable, and DNS server should have entry record. Okay. Then if everything is okay, then we should get the host name resolution also. And if there is a ACL or if there is a firewall in between, that could also block the traffic up to DNS server. So we have to remove all the blockage, and we have to cross check this DNS server is reachable. If DNS server doesn't have record, it should get this from root DNS server. Next important question for us is how to find the uptime of router and switches. So I have one lab running here. So if I click on this router and if I run command show version, okay, it should show me what is the uptime. Okay, so you can see here the uptime is 1 day, 14 hours, 59 minutes, and 40 seconds. So it keeps on incrementing. Now it is 53 seconds, right? Now it is 59 minutes and 59 seconds. Now it will become 15 hours. Now you can see here 1 day, 15 hours. Okay. So from here, show version command on the privilege mode, we can easily find out our uptime of the device, whether it is a router or switch. Next question is, what is VPN? on the answer for this. VPN is virtual private network. Virtual private network. So we have different types of VPN, like a GRE VPN, IPsec VPN. Okay, uh, so there are different types for this, but let's understand first what is the purpose of VPN. So we'll try to understand this with the help of diagram. So suppose here we have a server. Okay, the server we have, right? And employee sitting in the office can easily reach to this server because they are in the same network. Okay, so it is the private network, like this is 192.168.1.0. Okay, so this 192.168.1.0 network, the client will also have the IP address in the same range. For example, 10 here, 192.168.1.10, 192.168.1.20, right? Suppose the IP address is 192.168.1.2. So these client computer can reach to the server easily because they resides in the same private network. But suppose a employee wants to access a network from his home or from the internet. Okay, so this server, suppose a database server, we are not allowing access to this database server from the outside, because web server is a public facing server, DNS server is a public facing server, they can access it, right? But for this database server we are not allowing access. So what we have, because of security reason, so suppose a few database administrator wants to work from home. So how we can do that? So we can form a VPN tunnel. Suppose this user is at his home, okay, and he wants to access a the database server here, right? So we need to form a VPN tunnel for this. So VPN tunnel will be formed, right? And through this VPN tunnel, our traffic will go in encrypted form in IPsec, and then we means this computer will get the same IP address in the range of 192.168.1.0. So suppose here we got the IP address 192.168.1.30. So physically this computer is here, right? But logically or virtually this computer is near to the server. Okay, so it is logically here. So virtual private network, it's not because we are actually using public network, and we are making it a private network with the help of IPsec tunnel. So we have to use tunnel for this. Okay, and normally in case of IPsec it is encrypted. If it is a GRE tunnel, then it is unencrypted. So most of the cases we have to use encrypted tunnel, but in certain situation we can use GRE as well. And if we require GRE as well as IPsec, so we can use GRE over IPsec for the encryption purpose also. Next important question in our discussion is, what is BGP? BGP stands for Border Gateway Protocol. BGP protocol works on port number TCP 179, and it is a routing protocol, but it is exterior gateway protocol, means it works in inter AS. AS is autonomous system. So most of the internet backbone is working on BGP. So it supports large or huge, the more appropriate word is huge routing table where lakhs of routes are available. And we have traffic engineering options in this. Okay, so lots of traffic engineering options we have in BGP. Okay, so if we have multiple internet connection or multiple connections with different AS we want to connect, right? In that case, BGP is a preferred routing protocol. Next important question in our discussion is, what are the memories used in Cisco router? So we have ROM, we have RAM, we have NV RAM, we have flash memory. Okay, and we have config register, but that's not normally counted as memory. It's just a setting related to setting. So ROM means read-only memory, that we know what it contain. ROM contain ROM contains our BIOS of the router, and the post process normally works through that. Okay. Then we have RAM, which contain a running configuration. Then we have NVRAM, which contain startup configuration, and flash contain iOS and some other important files, operating system. Okay. So these are the important memories and what files they are containing, that also I mentioned here. Next important question is, what is latency? Let's find answer for this. So latency is delay in packet to reach to destination. So from source to destination. So if I show you the delay here, so this is a latency we have, like 1 millisecond, 10 millisecond. If I just ping to 8.8.8.8, okay, so this is a latency we have, okay, 7 millisecond, right, 6 millisecond. Okay, so it is in millisecond, it is accepted. If it is going beyond limit, like 400 millisecond or 500 millisecond, so we may face issues on certain application like VoIP. Next important question in our discussion: why does congestion happen? So if we have resources or link is used by multiple client computers, multiple source computer, we can say. So there will be a starvation on the bandwidth, right? Or there will be a load on the resource, okay? And because of the congestion can happen. If I take an example, for example, if in the morning we move on the road in the city, we don't face any congestion because very few people are accessing that road at that time in the early morning. But as the time passes, by 9 o'clock or by 10 o'clock, the office time, multiple vehicles try to access the same road, and there will be a jam on the road or congestion will happen, right? So likewise here also, if multiple traffic flows are there, right? So multiple source traffic flow trying to access the same link, okay? So link used by multiple, or we can say, let me put it in another words, multiple traffic flows on same link or resource. Okay, so this is a common problem. If we don't address it, we may face some quality issues. Next important question for us is windowing. What is windowing? So this term is used in TCP protocol. So maximum, how many segments, max number of segment, TCP segments sent by sender, transmitted by sender. After that, uh, after that maximum MSS, maximum segment, maximum number of segments we can receive. Segment we receive acknowledgement from the receiver. So it reduces overhead on TCP communication. Otherwise, we would have to acknowledge each and every segments, and that's not possible, right? So we receive a chunk of segments, and then we send a acknowledgement message from the receiver to the sender. Next important question is, what is VLAN? So VLAN stand for virtual LAN, local area network. So it's segment network into sections, smaller and manageable. So these segments we can do for different departments like IT, HR, okay, and we can do it on the location wise also, like floor 1 or floor 2 or data center or employee network. Okay, so it divides into multiple broadcasts. So if we have two VLANs, means two broadcast domain, okay, and we should have two subnets, separate subnet for them, IP subnet. So it improve security and performance of the network. Next important question in our discussion is trunking. What is trunking? So it is also called as tagging as well. It is used for switch to switch communication connection, we can say, where multi VLAN traffic is required. If we have access link, only one VLAN traffic will be entertained. If we have tag link or trunk link, we can transfer multi VLAN traffic. So it normally use IEEE 802.1q protocol. There are some other protocol also like ISL, but this one is normally used because ISL is obsolete now, which contain VLAN ID information. Next important question in our discussion is spanning tree protocol. Stands for STP, stands for spanning tree protocol. It used to avoid or prevent switching loop. So by avoiding switching loop, we avoid the broadcast roam and MAC instability. So it works with BPDU, bridge protocol data unit. Okay, and if we have a loop in the network, right? So the best switch will be elected as a root switch. Okay, and redundant links are logically off. Whenever required, these links will be utilized. Okay, so if primary links or the important links which take us to the root switch goes down, then this redundant links are utilized. Okay. Next important question is, how do OSPF routers form a neighbor relationship? To understand this answer, we have to go through this diagram, or and at the time of interview also we can just explain with the paper or with this diagram. So suppose two router wants to form a neighbor relationship. So just with the help of two router, we try to understand this process. So initially it is in the down state when you run a router OSPF command, router OSPF1 process ID 1 suppose, and if you give the network, suppose here we have a network 192.168.1.0, so it goes into init state and it starts sending hello packets over this link, and this R2 will receive this. It will also enter into init state. Okay, but there is no neighbor mentioned in OSPF hello packets, right? As R2. So for R2, this will be init state. Then R2 will also send hello packets to 240.0.5 multicast. It will be destined for multicast IP address, and then R1 will go into two-way state. Reason, the hello packets received from R2 will have R1 as a neighbor. Whatever the router ID of R1 will be listed as a neighbor, right? And then both will then R1 will also send a hello packets with R2 as a neighbor, and both will know each other. They both recognize to each other, so that's why they will become a neighbor to each other, right? After this, we have adjacency formation. So DR will be elected provided we have a we have a broadcast broadcast network here. So if it is a switch, then it is a broadcast network. If it is a serial link, then it will be point-to-point network where DR is not elected. Okay, so it is optional step, depends whether we are using a broadcast network or a point-to-point network, right? So after that, it goes into Xstart where the primary and secondary routers are selected. Its actual term is master and slave. So whoever has a better router ID will be elected as a master or primary router, and the next one is a secondary. Okay, and primary will exchange a DVD first, then secondary will exchange a DVD which contains the information about information about the whatever LSAs we have on R1 and whatever LSAs we have on R2. They will load each other, and whatever missing LSAs are there, that will be shared with a link state request and link state update and a link state acknowledgement message. At the end, they both will have same state of LSAs, means LSDBs will be same on both the routers, and that will be considered as full state. They form a full adjacency with each other. So this stage is neighbor relationship, and this stage is like a fully adjacent formation of the neighbors. Next important question is how DR is elected. So for this, again, I'm referring one diagram. So you can see switch is connected with multiple routers. So one of the router will be acting as a DR, the next router acting as a BDR, and the rest all router will act as a DR others. So how it will be elected, like this is ADR, this is BDR. So we have a router priority first. So if router priority is higher, that router will act as a DR, and the next one as a BDR. But suppose by default all of them has same priority, and that is priority number one, right? So that's not a tiebreaker then. Then higher router ID will be elected as a DR. Okay. So whoever has a higher router ID, for example, here suppose we have 1.1.1, 2.2.2, 3.3.3, 4.4.4, and 5.5.5 and 6.6.6. So this is higher router ID. So this router will become DR and this router will become BDR. Okay. And suppose initially 1.1.1, these all routers are off, only this router is on and it has started with OSPF. Then this router will declare itself as a DR even though it has a lower router ID. Once it is become DR, after waiting timer of 40 seconds, it's declare itself as a DR. Then other router has to consider, if they came up afterward, then they have to recognize this router as a DR. Okay, so it is a non-preemptive process. So here we can mention a few points. First is priority, and second is router ID, and it is non-preemptive. Waiting timer is 40 seconds. Next important question in our discussion is LSA, and especially type 3 LSA. So let's have a answer for this. So LSA stands for link state advertisement. Okay, we have type 1 LSA as a router LSA, type 2 LSA as a network LSA, and type 3 LSA as a summary LSA. Summary LSA. So when we have multi-area OSPF configuration, then only you will see this type 3 LSA. So summary LSA or summary network information from one area to another area is type 3 LSA. Okay, from one area to another area is in the form of type 3 LSA. Who will generate this type 3 LSA? The ABR, that is area border router, will generate this type 3 LSA. Next important question is from EIGRP. So what is feasibility condition? Feasibility condition says like reported. So for feasibility condition, I'll refer this document. So reported distance of additional route should be lesser than feasible distance of successor. Okay, so let's take this. Okay, so let's try to understand this with the diagram. So you can see here reported distance from R2, R3, and R4. So here a reported distance from R2 is 6,000. As you can see, 5,000 plus 1,000 is 6,000, right? Reported distance from R3 is 10,000 plus 1,000, that is 11,000, right? And reported distance from R4 is 17 plus 1 is 18,000, right? So the lowest one is 16,000. Why it is 16,000? The feasible distance is this the distance to reach to R2 plus the reported distance. So 10,000 plus 6,000 is 16,000. That is successor, right? That's the best path. And R3, we have 7,000 plus 11,000, right? 7,000 plus 11,000, that is 18,000. That is a feasible successor, we can say here. Why it is feasible successor? Because a reported distance is 11,000, right, from the additional route, which is lesser than 16,000. That is a feasible distance of successor. That's why it is acceptable. But in case of R4, this reported distance is 18,000, which is higher than the feasible distance of successor, right? That's why we will not consider this as a feasible successor. That's why it is not applicable. That's what the conditions say. The feasible distance of successor should be more than the reported distance of additional route. But in this case, the additional route has a reported distance of 18,000, which is more than the feasible distance of the successor. That's why it is not counted as a feasible successor. Next important question in our discussion is NAT. It stands for Network Address Translation. So normally we use it for private to public IP address translation and vice versa. So on the edge of the network, this service is normally implemented either on the router or a firewall. So we have different types of NAT. So NAT overload normally we use for this purpose to access internet. But for incoming traffic, especially if you have public facing server, that time we use static NAT. We have dynamic NAT as well, but these two are the more common one. Next important question, and that is the last one in our discussion, is handshake, three-way handshake. So three-way handshake is used in TCP to establish connection. So the sequence of messages which is used in three-way handshake is SYN, SYNAC, and ACK. Okay, so these three sequence of messages are to and fro. So suppose client wants to set up a connection, so it will send SYN message, server will send a SYNAC message, and then client will send an acknowledgement message. Okay, then the connection will be established, then the further processing of the communication will happen. For example, if it is HTTPS based, then the SSL communication will start happening after that.